Welcome back, Calculus. Our objective for today is going to be to solve some more motion problems involving differential calculus. I have the checklist on the screen. You know what to do from here. Alright, so I've got example 1 here. It says if the position of an ant traveling along a horizontal path at time t is given by x of t equals, and could you just write this part for me, please? Negative 3t squared plus 1. What's the ant? And then go ahead and write average velocity from 1 to 3. And I'm using a different tablet, so I apologize. My writing might not be so great for this. Okay, so average velocity. Well, velocity is the rate of change of what? Velocity is the rate of change or derivative of position. So if I want the average velocity or average rate of change of position, this would be average value. So x of 3. My position at 3, minus x of 1, all over 3 minus 1. Okay, so let's go ahead and find that. To find x of 3, I'm going to plug 3 in for t here, right? So 3 squared is 9, times negative 3 is negative 27, plus 1 is negative 26, minus. All right, now let's plug in 1. 1 squared is 1, times negative 3 is negative 3. Plus 1 is negative 2, so minus a negative 2 or plus 2 here, all over 2. So I'm getting negative 24 over 2, which is negative 12. Good deal. All right, now what if instead of average velocity, I asked you to find the instantaneous velocity at x equals 6. So I'm still going to use x of t, the position. So how is instantaneous velocity related to position? Well, v of t is equal to the derivative of position, right? So the derivative of position in this case is going to be negative 6t, right? The derivative of 1 goes away. So if I want velocity at 6 seconds, that's going to be negative 6 times 6, which will be negative 36. Okay. So remember that velocity gives us speed and direction. So what is the ant's speed at time 6? Well, the speed is going to be, let's see, the speed is going to be 36, whatever units, miles per hour. And what's the direction in this case? Remember that it's just traveling horizontally, okay? So the direction in this case is left, and why is that? That's because the velocity was negative at time 6, okay? So I'd like for you to write this. Speed is equal to the absolute value of velocity. Okay, and that's a really important concept. So we've got position, velocity, and acceleration. If I want to find speed, I simply take the absolute value of velocity. So I'm going to force a pause on your screen. You'll probably need to pause as well. But go ahead and copy my table, and then we'll fill it in together. Okay, we are back. So I've got some different velocities at time 1. So notice both of these velocities are at time 1. And then what I'm going to do is assume a constant acceleration of either 1 meter per second squared or negative 1 meter per second squared. So let's talk about the difference. If my acceleration is 1 meter per second squared, that means for every second, I'm gaining another meter per second for my velocity, okay? If it's a negative 1, I'm losing a meter per second every second in my velocity. So my velocity is decreasing, which doesn't necessarily mean that speed is decreasing. So we need to kind of take a look at the difference here, okay? So I've got my velocity at time 1, and what I'd like to do is see, okay, what's my velocity at time 2? Okay? So if my velocity at time 1 is 10, and my acceleration is 1 meter per second squared, then at time 2 I've gained another meter per second squared. So at time 2, my velocity is 11 meters per second. So let's fill that in together. If, however, again, I start at 10, but my acceleration is negative 1, where would I be? I'd be at 9 meters per second at time 2. I've lost 1 meter per second. Okay, let's start at negative 10 meters per second. If my acceleration is positive 1, well, negative 10 plus 1 is negative 9. Okay. And then if I start at negative 10 and my acceleration's negative 1, now I'm at negative 11, right? Meters per second. So now let's talk about speed, okay? So for this first one, my speed was 10, right? Take the absolute value. I went from 10 to 11 in this first box. So am I speeding up or slowing down? Speeding up, right? Let's see if I can get this to write. Let's see if I can write and spell. So here I'm speeding up. And then in the box underneath, again, I started at 10. That's my speed, right? Take the absolute value. Ended at 9, so I am slowing down. Okay, let's take a look at what the third box we filled in here. So if I come over here, I started with the speed of what for this box? My speed's 10, correct? Take the absolute value. And now my speed is 9. So if I went from 10, a speed of 10 to a speed of 9, we are slowing down. All right, and then for the last one, I started with a speed of 10, ended with a speed of 11. Make sure you're taking the absolute values. So for that last box, we are, what, speeding up or slowing down? We are speeding up. So take a moment to kind of look at when were we speeding up, when were we slowing down. Notice that when your colors match, when you did blue and blue, or red with red, you're speeding up, okay? So when your velocity and your acceleration were either both positive or both negative, you're speeding up, right? Because if you are moving to the right and your acceleration's positive, you're going to move to the right even faster. If your velocity is negative, you're moving to the left, and if your acceleration is also negative, then you're just moving to the left faster, okay? Now, if velocity and acceleration have opposite signs, take a look at like this box and this box. So you had one positive, one negative, then you're slowing down or your speed is decreasing. So let's go ahead and put that in our notes. I'm going to force a pause on your screen and go ahead and copy what I have, and then we'll fill this in together. So a particle is going to be speeding up, or you can say speed is increasing if velocity, so I'm going to put v of t and a of t have the same signs. So both positive or both negative. Okay. The particle is slowing down or the speed is decreasing if v of t and a of t have opposite signs. So one positive, one negative. Okay. All right. So go ahead and copy this as well. So let's just again make sure we know what all these symbols mean. Assuming that s of t gives me position, what does s prime of t give you? This gives you velocity. What does s double prime give you? That gives you acceleration. And what about the absolute value of the first derivative, so the absolute value of velocity? That gives you speed. Good deal. Okay, I'm going to force a pause on your screen. Will you please copy what I have? Okay, so we're given v of t, velocity, and we want to find all values of t in the interval 0 to 6, where the speed of the particle is 3, okay? So what is speed? It's the absolute value of which function? It is the absolute value of v of t. And by the way, that little asterisk up here means that it's calculator active, okay? So I want to know for all values, where is v of t, absolute value of v of t equal to 3, okay? And that would be the same as if I want to drop the absolute values on the left side, that would be the same as saying that the velocity is either plus or minus 3. Okay, so we want to solve this. It's calculator active. So how I'm going to encourage you to do it is put v of t into y1, and then put 3 into y2 and find their intersections, okay? And then do the same thing for -3. So let's do this together. Let me pull out my calculator. So I am going to put v of t in y1, which was t, and we're going to use x if you're in on an 84. So x times sine x. Then I'm going to put 3 into y2. I do my intersections pretty quickly, so it will work better, I think, for you if you just focus on 2 graphs at a time, okay? So now, before you get too hasty with the graphing, be sure you set your window. What do you think I should set my window to? This is really important right here, okay? That is my x min, x max. So I'm going to go 0 on my x min, 6 on my x max. Now for my y min, y max, I'm going to graph y equals 3 and eventually -3 as well. So I'm going to go ahead and do like -4 to 4 on my y's. All right, now we can hit graph. Any intersections there? No intersections, but am I done? No, now I need to also check for -3. So now I'm changing this to -3. We'll graph this. So notice I've got 2 intersections. To find an intersection, you're going to go second, trace number 5. Please write that down if that's not familiar. I like to hover over to my line, get close to that intersection, and then hit enter 3 times. And you can only do it again this fast if you've got only 2 lines, okay, or 2 graphs. So I'm getting 3.991 if you truncate, or 3.992 if you round. Either one is fine. And there's a second intersection, 5.734. And again, the calculator commands there are second, trace, number 5 for intersect, and then just get close to your point of intersection, hit enter 3 times. All right, let's take a look at the second part. So this one says find all times t in the interval 0 to 6 at which the particle is at rest. Justify your answer. Okay, so this is going to actually be very, very similar to what we just did. If I'm at rest, what is my speed and or what is my velocity? If I'm at rest, my velocity and my speed are both 0. Okay, I'm not moving. So what I want to do is solve the equation v of t is 0 in this case. So v of t is 0. And again, really similar to what we just did, we are just going to change that -3 to a what? To a 0. Make sure you're writing this. All right, my window is good already. I already have it set to 0 to 6. So when I graph this, it looks like this, and I found the intersection already. You can see it's pi, as well as 0, right? So my answer is t is 0 and pi, or you can round pi as well, either way. My justification is actually simply showing this equation here. So since I showed that equation, that is all I need. Just be sure that you don't just throw in an answer, okay? But it's 0 and pi since v of t is 0 there. Okay, so this next one says find all times t in the interval 0 to 6 at which the particle changes direction. Justify your answer. Well, remember which function gives me direction. Velocity gives me direction. Now I'm looking at velocity as a graph. So remember, if velocity is positive, I'm moving to the right. If velocity is negative, I'm moving to the left. And what do I mean for a graph to be positive? That means the y values are positive. So that means I'm above the x-axis, okay? So velocity is positive here, and then it dips to negative, okay? So where does the particle change direction? here at pi, right, at 3.141 if you prefer. And what's the reasoning? Because velocity changes from positive to negative there, or you could say because velocity changes signs there, okay? So let's write that. T equals 3.141 since v of t changes what there? Signs there. Okay. Or you could say since v of t changes from positive to negative there. Okay, so this last one says, is the speed of the particle increasing or decreasing at t equals 4 justified? Well, remember the conclusion we made over here was that the speed's particle is increasing if velocity and acceleration have the same signs, decreasing if they have opposite signs. So, let's work with that. Let's find velocity and acceleration at t equals 4, okay? Now, I already have velocity plugged in, right? That is my y1. So let's go to our home, and let's find velocity at time 4. So remember, alpha trace enter gives me y1, open parentheses at 4. Okay. So y1 of 4 is negative 3.027. Now how would I find acceleration? That would be the derivative of velocity, right? So on an 84 we go math 8. And then again, alpha trace enter to grab y1. And again, I'm looking here at x equals 4. And that's also negative. So what do you say? Is the speed increasing or decreasing? It's increasing because I'm going to the left and my acceleration is also negative. So I'm basically my velocity is becoming more negative, if you will. All right, so this is your justification. You need to state what you got for your velocity. Remember, that was just y1 of 4, and your acceleration. So that was the derivative, math 8. And then we'd say increasing since a of 4 and v of 4, that's a 4, not an 11, have the same signs. Don't just put this statement here without telling us what you're getting for v of 4 and a of 4. Otherwise, it just looks like you're regurgitating a definition. All right, I'm going to force one last pause on your screen. Go ahead and write these if you feel like you need them. And then I will see you all next time.